why is blockchain so important? This really helps in sort of helps in trying to get a perspective that why we should be interested into blockchain, right? So as said, almost 10% of the global GDP is going to be stored in blockchain in a couple of years from now, right? As we are already aware, a lot of banks have already some applications on blockchain, and they are continuously evaluating how they can bring in more applications on blockchain, right? So there is even a couple of dedicated consortiums also which are formed around banking. We'll discuss more of that when we talk about the use cases later on. So and yes, of course, the value, that the business value which is basically being added by blockchain, almost like 176 billion, which is going to exceed up to 3.1 trillion, right, in maybe next few years again. So now the major challenge that we see there is, right, the knowledge gap, the overall trust gap. That's what we are looking to sort of bridge through these programs, right? I'll try to take a simple example, and then I will, go ahead with my presentation. Now, I'm sure you're all familiar with supply chains, right, where there is a lot of material going back and forth between multiple stakeholders, right? You talk about food supply chain, you talk about a car manufacturer supply chain, whatever. This is a simple example, right, which talks about a car manufacturing supply chain, right? Now, if you see there are hundreds of suppliers which are providing the manufacturer the components of the vehicle, components of the car, right? And then the manufacturer may have tens of plants where they are doing assemblies, right? So there may be an engine assembly plant separately compared to there will be a shipping plant. They may have a testing facility separately, right? And then they would actually bring all of these things together to an assembly line. And then again, they may have multiple plants for assembly as well, right? And from the assembly line, the manufactured product or the car actually goes to multiple dealers, and finally they land up with the customers. Now, if you see the entire supply chain, there are hundreds and hundreds of moving parts in this, right? Whether suppliers or manufacturers or dealers, whosoever we're talking about, right? Now, it's really very difficult to manage this in a conventional approach, right? We'll see that how. So that's where blockchains really come up. This is another example where we talk about a food supply chain, right? Again, you can see there are multiple stakeholders, right? From seed provider to fertilizer providers to merchants to third-party equipment suppliers. A lot of there. Then you have entire food industry there. You have financial services there. You have insurance companies coming in now. Now we see in agriculture there is a lot of insurance industry which is there, right? So the point is there are a lot of people, there are a lot of stakeholders, and there may be a lot of intermediaries as well, right? And the current state of things is more like paper based, right? Which is not almost or always in real time. And each of these stakeholders maintain their own record of transactions in their own ways, right? They may not be compatible, right? Somebody, let's say a farm owner, the way he manages his record, even in case he manages, may not be the same way, how a corporate, agriculture corporate maintains the records, right? So, and it's really difficult to reconcile when you are having or you're looking to map the records back to where it originated from. So that's where is the challenge. Similarly, if you talk about, how in international trade payment system, right, cross-border payment system, how the payments are done today, this is again a very complex chain with multiple intermediaries and hardly any transparency, which is even costly because of multiple intermediaries sitting in between, right? So again, blockchain is revolutionizing or changing the way it happens here. So when we talk about blockchain, we talk about multiple technologies, multiple multiple things together, right? Whether it's mining or it's consensus or hashing or ledgers or peer-to-peer networks, whatever, right? So we talk about multiple things about. I'll skip a few things because I'm sure you're already covered all of these, where we have a genesis block, then you have multiple blocks come and getting added to that overall chain of things, right? We will broadly focus on two things: consensus algorithms from a Hyperledger point of view, and how transactions happen in a Hyperledger scenario, right? I'd like to draw your attention to this. In all the previous slides, we talk about talked about the conventional approach, a business approach, where there are multiple stakeholders who are managing their own system of records, right? Now, mostly paper based, and the major problem with this is, all of these actually are like, there's so much of redundancy in this, and they're in silos and they're not talking to each other. So it's really difficult if you want to sort of see them in the. So if you want to ask a particular transaction, what's the state of a transaction at a certain time, the state of transaction may vary for all the different participants, right? Because all of them will derive their truth from their own system of records, right? And so let's say a simple example. Let's say A is a buyer, B is a seller, right? I'm taking a very basic example here. Now, A made a remittance to B as an advance for buying something, right? So the moment A made that remittance, A's bank account gets debited with that X dollar or X value, whatever excess, whatever participant A is paying to B as an advance. Whereas it will take a few days to reflect, in B's account, right? So if you see there is disparity in the accounts at given point in time, isn't it? So it's really important that we understand that how the vulnerability gets added because of this inefficient mechanism of storage of records, right? Now, what blockchain brings to the table is a consistent approach, which has a shared, replicated permission ledger sitting between all the network participants, which provides for consensus, provenance, immutability, and finality. So I understand that you would be familiar with all of these things. So I'll not dig into all of these for now, right? So broadly, 4 things that we talk about as requirement for business and as far as blockchain is concerned: a shared ledger, which basically has, is a ledger between all the participants. Then an identity, right? That's where we differentiate from a public permissionless blockchain, right? An identity, because when you are doing a business, unless you are doing a business on a dark web, you need to know whom you are doing a business with. So hence, identity of the participants is very important. Then endorsement, we'll talk about it in detail. And of course, the confidentiality, right? Like how much information to be shared with whom on this network. And that is basically on a need to know basis. So we control all of that through cryptography. This is just a recap, which you would already be knowing about, like how you control the identity, how you do the endorsement. We'll see that from a fabric point of view, and how cryptography is key whenever we talk about maintaining privacy and confidentiality on the network, right? So what is the benefit that the blockchain brings to the table, right? It basically brings that irrefutable proof for any transaction to have occurred, right? And so this proof is really something which is important. Now, a lot of our activities on a day-to-day basis, if you do, we are very skeptical when we do it. When we make a payment to somebody whom we don't know, and when we make a buying agreement, or when we purchase something of high value, trust is something which comes everywhere, right? To in the middle of that transaction, right? And that's where blockchain really comes handy for adding that irrefutable proof that that transaction did occur, right? And you can revisit that proof every time back and again, right? Wherever you want to. Now, I want you to actually, I'm sure you might have been doing this, but then I want you to actually think through, and we'll come back to this question again in later on. Think of an example, think of a place where you would like to implement blockchain as a technology in your day-to-day, whatever you do, right? Whether you are teaching, whether you are doing research, whatever you're doing, try to think one example. How do you think blockchain can make things better for you there, right? And we'll come back and we'll discuss more of this again. So let me go back and let me go to the Hyperledger that we are going to talk about today, right? Now, as we all know, Hyperledger is a collaborative effort which was created to advance blockchain technology, right? And not very old, right? This project actually was founded in 2016, and since then, if you see on the right hand side the different logos there, so those are different type of partners, right? There are premier partners, there are general partners, there are associate partners, there are even academia associates who are connected with this project, right? So Hyperledger Fabric is actually one framework, which is one under the Hyperledger umbrella, and there are so many, right? For Fabric, there are multiple contributors, including IBM, DTCC, Fujitsu. There's so many of them you can see over there, right? So IBM is just one of the contributors to the Hyperledger Fabric platform. And then there are so many other other frameworks like Iroha, Sawtooth, and so many more of them, right? Now, why Hyperledger? Why we are talking about Hyperledger today? And I'm sure you might have gone through a few more frameworks from few more platforms in course of last couple of days, right? Now, from a enterprise adoption point of view, right? No enterprise, let's say if you're looking to adopt to blockchain as a technology, right? So you're looking for a like 50, 60, 100 years of particular technology adoption, right? And hence, no enterprise would like to get into a vendor lock-in. Now, what I mean by vendor lock-in is you subscribe to a product from X vendor, and then you cannot move out of that arrangement even if you are not happy, right? I'll give you another example just to clarify my point. Let's say you decided to have a university management system developed in, let's say, Java, right? At some point in time, it seems that you are not happy with Java, or it seems the functionalities that you want to implement are no more supported through Java. Again, a hypothetical example, right? And then you want to move on to, let's say, C#, just an example, right? Now, in order to do that, maybe you'll have to rewrite the entire code. That means, the entire effort. And besides the overall journey that you already would have with that application, let's say you already had implemented for last 20 years that Java program that was running the system for you, the application for you. So that means all that 20 years of record, besides, and the entire redevelopment of the application in, let's say, C# is a humongous effort, and of course a cost taking as well, because you'll have to have systems in place, you'll have to have a development team in place, you'll have to invest some time in that. And then you'll have to find ways to port the historical legacy data back into the system so that you can leverage the historical transactions that has happened in past, in the last 20 years, right? So all of that is like, you're getting logged into a particular platform. Here we're talking about a vendor lock-in. So from an enterprise point of view, why is Hyperledger important, right? Because it provides for open governance, right? So there is no one organization which is controlling the entire project, right? And hence, there is no lock-in with one particular vendor. So let's say there is a company, IBM has a use case on BNFS, right? Let's say MX has another use case, maybe in some other segment, right? So when you actually look from an application point of view, so the requirement of a blockchain platform can greatly vary across different use cases. There cannot be one size that fits all solutions. And hence, it's really important for an enterprise to look for a framework, to look for a platform which provides for open source, open standards, modular, pluggable options, so that they can switch as and when the requirement changes. And that's where Hyperledger has a clear differentiation from other platforms, right? Now, as I was telling about, right, there are multiple projects under under Linux Foundation Hyperledger project, right? So you got multiple distributed ledgers like Besu, Burrow, Fabric, Indy, Iroha, Sawtooth, right? Similarly, you got multiple libraries like Ursa, Quilt, and all, right? And again, they're provided for a lot of tools which can be used on top of this, like Avalon, Cactor, Caliper, Cello, and all, right? So this is actually a very broader umbrella which provides for a lot of great things. So from a Hyperledger point of view, the objective is to create an open source distributed ledger framework and provide the code base upon which users can build and run robust platform specific applications, right? And again, at the same time, it's also the intention to provide a technical community which can work for benefiting, or which can work for upliftment of the platform, right? So if you see, there is a very strong Hyperledger community which keeps on adding to various things, various components. You can even go ahead and you can propose some labs there on the Hyperledger. You can even go and add and suggest those there. So a lot of stuff around there. which provides for open standards and open governance of the project. Now, ever since the first release 4.6, Hyperledger Fabric has seen multiple releases in the last couple of years, right? Now we are actually going with 2.x series right now, right? So we'll try to discuss the latest one there, what is typically there, right? But the key characteristics from a enterprise adoption point of view is permissioned blockchains we're talking about. They should be providing for privacy. The solution should be, the platform should be highly modular, which can provide for pluggable consensus, ledger, certificate authority, whether external certificate authority or internal certificate authority, right? The smart contract should be supported by multiple languages, right? So right now, for example, for Fabric, we have support for Java, we have support for Node.js, right? We have support for Go, we have support coming up for Python, right? And here, from our enterprise adoption, we do not talk about any mining sort of a consensus mechanisms, right? So we have a couple of mechanisms approach which are implemented through ordering service. We'll see that in detail. So four key components when we talk about Fabric: one, the certificate authority; two, the peers; three, the ordering service; and four, the channel, which basically connects all these three stakeholders, right? So this is just one sample network where there's a farm, agriculture farm, there is a buyer, there is a shipper, and all of them are connected through channels. So we'll discuss more about channels in due course of time. Guys, in case you have any questions, feel free to put it on chat. I'll be more than happy to pause, take a look at the chat window, and maybe answer those questions in a while. Okay, so I'm sure you're already familiar with these typical concepts of assets, contracts, transactions, business networks, and participants, right? So participants are interchangeably being called as nodes. We'll use that terminology often when we talk about going further, right? Transactions typically are the invocation of algorithms, whatever we are looking to do on the network, right? Contracts are what we talk about as the algorithms, right? Which is agreed upon between you when you start doing something. And assets is something that changes hands, which is modeled as data structures, okay? So okay, just a moment, please. Okay, yeah. So what we are trying to achieve with Fabric is we are trying to achieve a multi-party transaction using Fabric, right? So a transaction is like when I sell my vehicle to somebody else. Let's say I sell my car to Samir, or I buy a car from Samir, right? So that change of ownership of that asset is basically a transaction whenever there is a change to the system, right? Similarly, whenever you write a check for somebody, there is a change in the overall bank, right? Whenever a student receives any qualification, let's say somebody completes his MTech, right? So that's basically a transaction which is sort of getting completed. So normally, when we talked about transactions are signed by single organizations, right? For example, if there is a degree to be signed, the degree would be signed by a typical university, so registrar or vice chancellor and all, right? Now, similarly, if you're looking to sign up or you're going to looking to make somebody a payment from a bank signs that payment transaction, right? So the point I'm trying to make is traditional transactions were more like single organizations. Now, what we are trying to talk about here is multi-party transactions where there are multiple stakeholders who are signing the transaction so that the transactions can be authenticated, so that the consensus can be arrived, and so that the transaction can be irrefutable, right? Yeah. So, for example, if you are trying to receive or send a parcel to somebody, right? So the sender and the receiver both sign that transaction. Now, let me make one thing very clear over here, right? So I've been associated with a lot of companies, startups who have been, whom I've been working with for adoption of blockchain as a technology. Now, blockchain as a technology only makes sense when there are external stakeholders to the business. Blockchain is not a good technology when you talk about implementing within your university, right? But then when you're looking to collaborate within multiple universities or maybe multiple stakeholders, like say some industries and few more universities, when you bring them together, that's where blockchain actually makes sense, right? Because there is an inherent issue of trust between these multiple external stakeholders, right? So that's why we're talking about multi-party transactions, right? So if you see there, if you see on the right hand side, the response is basically being signed both by the seller of the car as well as the buyer of the car, so that a transaction of car can be authenticated, right? Similarly, if you see, from a transactions endorsement point of view, Fabric is built on selective transactions. So we do not say that all the stakeholders should be, sort of validating or endorsing a transaction. I'll take you through an example when I talk about more about the consensus. I have a small, sort of a role play to do there. We'll do it there. So for now, we'll just try to understand, in order to be, for any transaction to be valid, right? The transactions should be endorsed using some endorsement policy, which should be agreed upon by the stakeholders. Now, what can be the size of stakeholders? Who would be the stakeholders? We're not getting into that for now, right? But in this example, the one that you see of transferring of a car, here, there are two stakeholders, the buyer and the seller, right? So the endorsement from both of them makes sense here, right? Or maybe the regulator, the government regulator, right? RTO or somebody else who is basically facilitating or vetting this transfer, right? This is just basically a snapshot which talks about transaction endorsement, right? So transaction can be invoked by somebody and it can be endorsed by somebody else, right? So depending upon the nature of the transaction, right? So let's say there is a transfer of a vehicle happening from an organization 1 to an organization 2, and the asset name is car 1, right? So if you see the statement there, so the invoked transaction is transfer of car 1 to org2, right? And who is invoking it? It is basically invoked by the owner of the transaction, which is org1. Now, see this needs to be endorsed by the rightful stakeholders, right? So here in this case, the rightful stakeholders are org1 and org2, which is the buyer and the seller, right? Similarly, if you see some other, let's see, some other transaction. So you'll find the set of endorsers to be changed according to the policy. Now, see, if you want to change the rules, let's say we want org1, org2, and the regulator also to validate the transaction, endorse the transaction. Now, if you have to update the rules, see the last entry there. You need to actually, update. You need to invoke the update policy, and which has to be endorsed by all the stakeholders in the system there, in the network there, right? So yeah, so let's go further and let's talk about a typical Hyperledger transaction, right? A Fabric transaction, right? So a structure of a transaction is like an identifier, which is nothing but the ID identification of the transaction, and then who is the proposer, right? Who is the initiator of the transaction, right? And then the response, we call it as RW sets, the read and write sets for the transaction. What will be the result of the transaction, right? And once the transaction is validated, that is, it is being signed by multiple organizations, that's when it actually becomes a transaction, right? It's not before that. So that's when the transaction is written onto the ledger and the asset transfer happens to take place, right? Okay. I'm sure you understand about smart contracts. We also call them as chain codes. So you'll see this term, getting used interchangeably. Now, a smart contract typically is the one which generates the transaction response, right? So in smart contract is like a business logic which is embedded in the code, right? And which is defined to control the access to the ledger. It is, it uses transactions to basically process it from the application, and the smart contract also does the execution. And of course, since the smart contract sits on multiple nodes, right? So accordingly, there can be a smart contract for different business activities. For example, in this case of a car transaction, let's say the buying and selling of a car is like changing of the ownership of asset. So for this, there can be one smart contract. Now, if you want to check the history of ownership of the asset, or if you want to check the history of accidents which might have incurred on that particular asset, let's say car, what's the insurance history of this car? Now, for that, there may be a separate smart contract for that, right? So that transaction response is basically being generated by the smart contract. And of course, we talk about a ledger, which is an immutable history of all the transactions, right? We'll see when we talk about from a fabric point of view, there are two data structures, right? One is the blockchain and other is the world state, right? So the blockchain is typically where we have all the historical transactions stored, whereas world state is something where the current value of a particular asset is stored. Let's say, for example, the one that I was talking earlier, let's say I'm looking to buy a vehicle, let's say I'm looking to buy a car from Samir, okay? So the current owner of the asset is Samir, okay? So if you see in the world state, the car one owner is Samir instead of Oktu, let's say Samir. Now, let's say I have completed the transaction. I have made the relevant payment to Samir, and the ownership has got transferred to me. So the moment that happens, the historical value of the car owner, which is Samir, gets into the blockchain, whereas the current owner of the car, which is money, gets updated in the world state. So the immutable ledger is the blockchain, whereas the world state is a mutable. You can always keep on changing, keep on updating that. Now, it's really important, from a permission blockchain's point of view, that all the users have an identity, right? Now, in Fabric, we provide for X.509 based certificates and private keys, right? And we have both an internal certificate authority, and we can even have an external certificate authority, which provides for various keys to the different stakeholders, different network participants. We'll see more about it in due course of time. Okay, let me go further. So as I was saying earlier, typically a blockchain network is a consortium of multiple organizations. Blockchain is not a good technology for single organization adoption. Why? Because of the overhead it brings in terms of consensus and other things, right? Within an organization, you do not have an issue of trust, right? Because you all are part of, the entire processes are part of one organization. So you do not need to bring in that angle here, right? There is a natural trust, whatever, different organizations, different departments are doing in one organization. When there are multiple organizations, doing businesses with each other, that's where you talk about, blockchain, right? So coming back to the same point here, before you start doing a business, you need to agree upon some business rules, some logic, some guidelines, right? That's where we talked about, the smart contract, having all the business logic embedded into it. And that's why we talk about the endorsement policy. What is going to be the endorsement policy? How are you going to accept whether a transaction is valid or not, right? So all that consensus mechanisms actually kicks in here. Okay. Now, from a blockchain point of view, solution point of view, there are two major components. If you see from an application side, right? One is the smart contract, which has all the business logic, and second is the underlying network, right? The business network, which connects all the nodes or all the participants of the business network, right? So broadly, if you ask me, two major components. One, the network part, the underneath network part, which connects all the participants, and second, the smart contract of the chain code, which sits on top of it, right? So typically, let's say there's an organization, there is a manufacturing corporation, there is a dealer corporation. Then if you see there are multiple nodes in each of these corporations, right? So in manufacturing, there is a peer 2, peer 1, peer 3, and then there is in a dealer corporation, there are again some nodes, peers are being used interchangeably, guys, right? So a peer typically is one which has a copy of the ledger, right? And then we have different types of peers. We'll have endorsing peers. We'll see more of it. For now, just try to understand that blockchain has two major components, right? The smart contract on top, and then the underlying network which connects all of them, right? So here we are trying to talk about the underlying network here, right? So there is a certificate authority, there is an ordering service, right, which basically tries to bind all of these things together, right? And if you see there, there are all of these things basically are connected to each other. Each of these nodes talk to the certificate authority in their relevant corporation. So manufacturing corporation have their own certificate authority, the dealer corporation have their own certificate authority, right? Whenever there is either a query happening or a transfer application happening, right, they all need to go back and they all need to, you know, write the transaction on their ledgers. Now ledgers are basically being they are residing on each of these nodes, right? And we'll see like how are these, which of these nodes have a copy of the ledger and which don't have a copy of the ledger, right? So we'll see that. Okay. So second component, right, the fabric piece where all the application comes and sits, right? Okay, let me quickly show you the various actors in a blockchain system. So so we have a blockchain architect, we have a developer, we have a blockchain network operator, right? This is where the segregation happens, right? So one piece is basically maintained by the network operator. Now, cloud service providers like IBM and a couple of others offer blockchain as a service, right? Using which you can spin up a blockchain, service instance, which takes care of the underlying network for you, right? So it will create up a network, it will spin up those multiple nodes, you can have multiple organizations created there, and you can have multiple certificate authorities for different organizations there. And so all the entire network pieces basically being taken care of by these cloud organizations, right? We'll see a demo of this service in due course of time, as we go further. And then comes the second part where you architect the solution, right? And that's where it's basically being developed by the developer and you put it. So that's the two components which I was talking to you. Now, from a actor's point of view, you have those blockchain users. Now, these blockchain users can have varied interest on this solution, right? For example, an insurance company can be more on this network from a from a overseeing perspective, whereas maybe a buyer or seller can be on this blockchain network, for doing a transaction. And then we have a regulator, right, which again performs oversight. And you have these membership services connected to this network. You can have traditional data sources being coming and getting plugged into the blockchain network. And of course, you have system of existing records which come and tap into the blockchain network there, right? So these are multiple actors there, and they manage different pieces in this overall network system, right? So, so as I said, right, the blockchain network operator manages the entire connectivity and monitors the network between multiple stakeholders which are connected on this blockchain network. Similarly, the regulator is more like doing the overseeing work, right? Just that the compliances are met, whatever checks and balances are being put by the regulator, they are taken care of, right? That's basically the role of the regulator over here. I'll give you an interesting story that how is regulator so important when you look to adopt blockchain solutions, when we talk about the use cases there, right? And then these are the various components in a blockchain system. We talked about all of these in different places, right? What is membership, what is peer network, what is ledger, what are the various events, what is wallet, where you store all the security credentials for the different nodes, all of them, right? So typically, a Hyperledger fabric network comprises of set of nodes, right? Org1, Org2, Org3, let's say in this case, right? And these peers are, again, they simplify or they signify different organizations that can be any number of nodes on that, right? These peers connect with each other. If you remember, we talked about channels, right? So they connect through channels, they communicate through channels. Now, the channel basically defines the scope of network. What does it mean? If Org1 and Org3 are directly connecting to each other, they may have a channel between them as well, to which Org2 is not a party. Whereas Org1, Org2, and Org3 can be part of one common channel on which whatever communication they do is visible across all the three organizations. At the same time, if Org1 and Org3 are connected on a separate channel as well, so whatever communication happens, whatever ledgers are basically maintained, those will be native to only those two orgs, Org1 and Org3. Org2 will not be party to whatever conversation, communication is happening, or whatever ledgers hold on that channel, right? So that's what the scope of network means. Okay, and each node can be part of any number of channels, so that's not the case. Okay, this is what I was talking to you about earlier. that here we talk about two data stores, right? One is a blockchain, which is nothing but a linked list of blocks, and second is the world state. So it's the blockchain which is immutable, right? Blocks cannot be tampered. Why? We know the hash of the previous block is used to encrypt the next block, and so on and so forth, right? So the first block of the blockchain is the genesis block, and then as you keep adding the blocks, right? And we just understood that the hash of previous block, so hash of n-1 block is used to encrypt nth block. Similarly, the hash of nth block is used to encrypt n+1 block, and so on and so forth. So the point is, the longer the chain grows, it's not possible to tamper. The moment you try to tamper, you even try to edit one bit in a block, the entire chain nullifies because the hash changes, right? So that's why it is typically immutable. Come the second data store, which is the world state, which is nothing but a key value store, right? And it stores all the outputs of all transactions, and this is something which is not immutable, right? So you keep writing onto that, right? Now, how do you actually work between the application and the these data stores there, right? So the application will typically invoke some query there, which is passed on, which is processed by the smart contract, and based upon that, it basically goes and it tries to query the world state or the blockchain, right? Depending upon how it actually wants to be. So in order to understand the ledger, right, applications submit the transactions to the network, right? And network is basically where the smart contracts are there with some set of parameters. Now, transaction order and output is agreed by the network through the consensus mechanism, which is already in place, right? And world state is complemented by something called as a private data collection. I'm parking this conversation for now. This is just a sort of a snapshot that how a particular private data collection looks like, right? What's the private and what's the public state? So a particular data store can be private to some some stakeholders, and something can be made available to all the organizations, right? So let's say in this case, the owner name may be private to, let's say, the RTO or the police, which may be owning the ledger, but then the car, the model name, the other specifications of the car may be available, on a ledger which is publicly available to all. Why? Because all the other stakeholders would be querying this ledger, right? Okay, so this is where we talked about how the application is interacting with the ledger, right? So you have a blockchain developer which develops the client application using SDKs. So if you talk about from a Fabric point of view, there are SDKs available for Go. That's the natural thing which the Fabric is written on. Then you have SDKs for Java, for Node.js, right? And then there is support for Python, right? So so using that SDK, the application actually connects with the smart contract, right? And it then, based upon what operation does it wants to perform, connects with the world state or the blockchain and accesses the same, right? On the blue blocks that you see here, those are the ledger. That's basically the ledger which we are talking about over here. Okay, I'll skip this private data collection. We will come back to this later on. Yeah, so we'll come back and we'll see the pieces later on, the private one. Let's talk about the nodes. What are the different types of nodes? What's their role here, and how do they actually they're instrumental in doing a transaction? So typically, we talk about committing nodes, we talk about endorsing nodes, we talk about ordering nodes or service, whatever you would like to actually talk about, right? So please notice the color coding there, right? We will use the same color coding as we go further, right? So each organization agrees to a certain policy, which we will be adopting on the network, right? So OC2 agrees to certain policy. So that this policy is nothing but like a constitution which actually every organization will agree to, right? So we're talking about a peer-to-peer network here, right? So every organization has the same authority over the network, right? There's no master-slave concept here. All organizations must agree to any change to the network, right? So if there is a change happening in by some transaction, so as OC2 gets updated, the same gets updated across all the other organizations. All or many, right? A majority of organizations must agree to any change in the network, right? and a majority of organizations, including the stakeholders, should agree to a change, right? It's really important. That's what the entire policy is all about, right? Hyperledger Fabric uses identity and policy throughout, so it's really important. That's why I said that towards the start of the conversation, we're talking about permission blockchains here. We're talking about private permission blockchains here, right? So typically an application connects to a gateway using an identity from the wallet, right? If you see, this is a snapshot of one organization. There are two peers, P1, P2, running a smart contract S, right? They will actually select a available network and a smart contract depending upon the business operation that we are looking to perform, right? Once they submit the transactions, right, A1 submits the transactions and checks their responses, they typically, disconnect from the gateway. Okay, so this is how, a submission happens. I'll show you the complete flow of the transaction in due course of time. This is only from a broader understanding that, how a SDK connects to an ordering service or to a membership service and so on, right? So before anything starts, right, a client application has to enroll with the membership service in order to get an identity, right? We said that. Now this membership service can be internal to the organization, or it can be an external third party as well, something like a VeriSign or somebody else, right, which can play that role, right? So you enroll. So once you get the identity, then you submit the proposal to the endorser node, right? I'll just explain that in more detail. I'm just trying to explain this infograph. The endorser basically, returns some responses. Based upon those responses, you forward all those responses typically, right, and to the ordering service, right? And then the ordering service provides all of them to the committing node, all right? And then finally the committing node again runs some smart contract based upon which it checks the validity of the submitted transactions. Okay, let me take you through this step-by-step flow, which talks about the complete transaction. So client application, let's try to understand the network first. So in this network, there are multiple nodes, as you see, right? E0, E1, E2 are the endorsement nodes. P3, P4 are the committer nodes, right? And then you see the smart contract, E0 is running a smart contract A and a smart contract B. Another endorsement node, E1, E2 are also running two smart contracts for business process A and business process B. Okay. Now, the committer P3 is running two smart contracts again. If you see there, one is for a process A and another for a process D there, right? Now, and then there is a ordering service. Okay, so we are talking about a high availability ordering service over here, right? Okay, so let's try to see what is happening here. So the client application through the SDK has submitted an application to endorsement nodes E1, E0, E1, and E2. Okay. Okay, let's see what happens next. So the endorsers basically execute the proposed transaction. Let me take the transaction. Let's say the client application is saying there is a variable called X is equal to current value of X is 20. And the request is to update the from 20 to 40, let's say, right? So the client the endorsers basically execute this proposed transaction, okay, and so the read write sets, okay, RW sets. Now once the endorser does this, it signs and encrypts the transaction and sends it back to the client application. Okay, the read write sets are sent back to the client application, and they also include something called as a version number, a record version number. This is really important when we talk about how do we check the double spend, and it's really important in the consensus process later on. Okay, so X is equal to 20, the proposed value is X is equal to 40, and let's say the version number is equal to 2. That means this is the second time that the value of variable X is getting updated. Okay, let's see what happens. So once the client application gets all of these responses from the endorsement nodes, all of these is basically submitted to the orderer so that they can, order this and the other transactions in a form of a block, right? So if you see there, this red dotted line is basically submitting our response to the ordering service, and then there are multiple other applications which are sending their responses as well to the ordering service, right? Okay, let's see what next. So the ordering service collects all of these typical transactions and puts them in a block for distribution to the committing peers, right? Now, depending upon what ordering algorithm, Solo, Kafka, or Raft, whatever, the ordering service does this, right? Once the committing peer validates the transaction against the endorsement policy, which is embedded in the smart contract, in this case, you see that a smart contract running there. It also checks whether the read-write sets are still valid for the current world state. Now go back to the same example, x is equal to 20. Earlier value was 20. You want to update it to 40, and you said version number is equal to 2, right? So during the time when the client application submitted the transaction versus the time till the committing node is validating this transaction, has there been any change in the value? Which may be, because we're talking about big network here. There might be multiple committers, there might be multiple processes which are looking to change the variable x value and so on, right? So there can be multiple transactions happening in parallel there, right? So that's where the committer would like to check whether the read-write sets are still valid for the current world state. That's where the version number comes and plays a major role here, right? Now, if the transactions are valid, the same are applied to the world state. That means the value of x from 20 gets updated to 40, right? And the reference of x is equal to 20 goes back into the blockchain, right? Okay, and once this updation is happening, the same is updated across all the peers which have that ledger which needs to be updated, right? So applications once registered has to be notified whether a transaction, when a transaction succeeds, right? And each of the peers which they are connected to gets the notification of this updation. So typically this is where how a transaction looks like, right? So this is again the same way we talk about how the query is happening in a ledger, right? So we told that there is a smart contract S running on the node P1, right? And there is a query which is coming up to for something to query about a asset called car1, right? So once that is queried through the peer, the response is sent back, and then this can be done in all the other organizations. So each application typically queries their own organization's peer, right? I'll take a pause here, and there are a lot of questions on the chat. Let me quickly have a look at those. Okay. Somebody is asking what a private blockchain means. Okay, so let me try to explain this. I'll try to take a use case which may make sense to you, right? So let's say there is a affiliating university. I'm taking some random names, please do not connect it to anything, right? So let's say there is an affiliating university called ABC University, and this affiliating university has 20 colleges under it, okay? And then there is another university called XYZ University, right? Which is again an affiliating university. Now, when you talk about a public blockchain, what it means is any organization, anybody can connect on that blockchain, right? When you talk about permissionless as well, then what it means is there need not be any explicit permission needed to join that blockchain. So hence public permissionless blockchain, right? Whereas when you're talking about a private blockchain, let's say in the case of this ABC University, right? So those 20 colleges which are affiliated to the ABC University are basically, and this is again a blockchain, right? So that means those 20 affiliating colleges have an identity through which they are connected to a private blockchain of ABC University, right? Now, here ABC University may look like one entity, but then there are 20 different organizations which are coming under the umbrella of ABC University, right? So hence I took this example. Please do not, misunderstand me. So private blockchain is something where you govern who can join, what role are they going to play in that network, right? So that's typically a private blockchain. So when you talk about enterprise means any organization, any company, how do they use blockchain? They majorly businesses are done in private blockchains, right? uh, but if you talk about like cryptocurrencies, Ethereum and all, typically that's we talk about as public permissionless blockchains, right, where anybody and everybody can actually join a network, do transactions, and all, right? Okay. So there is another question, like what are the popular job roles for a blockchain project in our enterprise world? Yes, sir, you're absolutely right. Developers are the one which are in high demand from a blockchain point of view, and then you have architects, who basically design the solution for you. So there are two major job roles from an enterprise blockchain adoption point of view: one, the developers, and two, the architects there. Okay, let me scroll through a few more of them. Let's see. Okay, Hyperledger means actually what? So Hyperledger is an umbrella project under Linux Foundation, which is open source, open governance based. It's like, and hence there are multiple projects, multiple distributed ledger projects, multiple libraries which thrive under the Hyperledger umbrella. So Hyperledger is a project under Linux Foundation. So what is a ledger, right? So for example, the attendance register is a ledger, right? Somebody is asking what is a ledger. So ledger is nothing but a register, right? So attendance register is a ledger. What do you do there? You register all the attendance of a particular day for a particular student, right? So what are you doing? You are recording, you are keeping record of some activity, right? So whatever transaction you do, you record that on a ledger, right? So that's what is a ledger. Why are we using Hyperledger? We're using Hyperledger because it provides for a great platform, for enterprise adoption. It's highly pluggable, it's highly modular, it's open source, open governance based, and hence it does not, create a situation of a vendor lock-in. When a certificate authority is used, doesn't the whole essence of avoiding third party gets dampened? Okay, so the certificate authority basically, no, I didn't get the question. So certificate authority can be internal, it can be external as well. Meaning you can have a third party certificate authority as well, right? So in case you're on a network which does not want to have an internal certificate authority, you can obviously go for external, which provides for a lot more confidence and a lot more trust between the business network participants, right? Maybe you can rephrase the question, Poonam. Okay. Okay. So what's Fabric and Hyperledger Fabric? Okay. So Fabric is the framework, is the name of the framework, right, under Hyperledger umbrella. So under Hyperledger umbrella, if you remember, there was an infographic which talked about multiple projects, right? There was Hyperledger Aroha, Hyperledger Sawtooth, Hyperledger Indy, Hyperledger Fabric, right? So Fabric is one framework for distributed ledger technology under Hyperledger umbrella. Is there a node treated as a base node in blockchain? All have same privileges? Yes, all have same privileges. That's why we talked about peer-to-peer networks over here, right? So no node has any special privileges when you talk about from a blockchain point of view. World state is stored where? So world state is typically stored at the node that we're talking about. Okay, Mashutosh. What's an immutable ledger? Okay, so let's say, let me give you again an example that you might be able to relate. So normally when you take our attendance every day, you log the attendance at the bottom, right? So let's say if there are 40 students in the class and the 27 are present in that class. So normally what you do is, when you are done with marking the attendance present and absent, you typically say 27 by 40, right? You lock it down. What are you doing it? By that way, you're basically sort of giving a figure so that nobody can later change the content or manipulate the ledger entries, right? The immutable ledger is where you can only write, you cannot add it, you cannot delete, right? So that's what is an immutable ledger. Okay. During requirement gathering, are all parties involved? Of course, Avtar, before doing this, all the parties are invited, and all they sit across the table to actually create that a smart contract thing, right? They need to agree upon the business rules and conditions before the business network is set up and the blockchain network fires up. So it's really important. Okay. Also, from an IBM's perspective, we have a wonderful approach we call as a design thinking way of doing things, right? So in design thinking approach, we bring together all the network, we bring together all the stakeholders, right? And then we brainstorm with them what is the pain point for them, right? And then in that entire iterative process, we go back and forth and we find the just a moment and we basically find the solution to this problem, right? So everybody needs to be brought on the same page before actually bringing or spinning up a blockchain network, right? So a smart contract is nothing but the business logic embedded into a software. Now, business logic cannot be done by one person. It has to be mutually agreed upon. Okay. How to start a blockchain? Okay, how to start? So whenever there are multiple parties looking to do business together, they can come together and then they can start a blockchain. Abhishek, no, mining and crypto is not a part of this. Okay. Okay. Okay, I'm now seeing the message. If version is stored in world state, then there is lock or update required by blockchain nodes required, because they have to update both world state and blockchain data. So Ashutosh, as I said earlier, right, the world state is basically the mutable data store, which is nothing but a key value pair, right? And so that is of course mutable, right? So people or nodes, whenever they are whenever there is a transaction happening, the world state gets updated, right? Okay, Anamika, the endorsement policy is basically the policy. Let me give you an example. So let's say towards the end of the semester, you have this attendance register, right? And you have the record of all the students. Now you go to the header department or the dean, and the dean basically tells you that all the students who have 70% or more attendance can sit in the term exam, right? So this is a policy, right? This policy is endorsing that unless a student has 70% or more, they will not be able to sit in the examination. So this is a kind of policy. Similarly, in a blockchain network, when will you agree to any transaction? Let me give you another example. So I paid Samir 20,000 rupees, okay, as an advance for the vehicle that he wants to sell to me. Now, when will Samir accept the transaction to be valid, right? When his account gets updated with 20,000 rupees, right? Also, when will he send me the car? He will only send me the car when I make him the complete payment. And when will I make him the complete payment? When I completely, I'm convinced that this vehicle belongs to Samir. It has no, accident record, or it has whatever is there, it's there available in the insurance system. So unless, so the entire transaction, the way it is governed, it's governed by that policy. That is what we call as endorsement policy. When will you agree to some transaction? All those conditions, rules are basically nothing but the endorsement policy. Okay. No, mining in crypto is not a part of this. What are the databases we use for storing the data in a blockchain network? So typically we talked about two data stores, the world state and the blockchain, right? And then we can have the traditional database which can be plugged into that. We saw that in the actors infograph when we were showing that we can also have plugged in as the historical databases there. Ledger and block are different or same? They are different things. Ledger is ledger is basically like a register, okay, which you record the daily attendances, whereas block is the when you update this register, this 27 by 40, right? The attendance that you logged, when you update this attendance on a software saying that today's attendance is 27 by 40, which you cannot change ever, right? And this 27 by 40 is concatenated with other attendance of the same day. Together they form one block, let's say, right? So in first lecture it was 27 by 40, in second lecture it was 29 by 40, in third lecture it was 35 by 40, right? So towards the end of the day, when you actually put all these values in the software, which can never ever be changed, right, and they are like sort of formed as a block, as a data for that day, that's what becomes a block. But the ledger is one that you are holding, right? Just to make you understand, Gulab. Okay, ultimate need is to save some information on the network. Yes, of course, we do save the information on the network. Okay, I did not get that question. Another question from a participant A underscore 2, course 1, course 2, course 3, course 4. Okay. Blockchain is used basically to avoid the third party interference. But if we have some certifying authority, then it is a third party. No, blockchain is usually used to avoid gatekeepers. Third parties are not always gatekeepers. Okay, so there is a difference to the two things. Okay, what is the endorsement? So please park this question for a while. I will answer this in very detail later on. So I have multiple slides on endorsement. We'll see that there. Can we say that the ledger is a way to record the transaction? You're absolutely right. That's the way to say. Every node has some privilege. Does it mean I cannot restrict a node's function to only view and the others to add information only? So Likita, nodes are all equal one to, and that's why we talk about peer-to-peer network. The privilege is the way cryptography handles the access of the ledger by a certain node. So that's where is the differentiation. Otherwise, the ledger is same on all the nodes. So whatever ledger is available at node A, the same ledger is available at node B, and so on, right? So there is no difference in the ledger in the copy. It's the same copy of the ledger. What is actually varying here is A may not have the same level of visibility of the ledger compared to what B has, right? So let's say A can view 3 fields in the data available on ledger, just giving you a very basic crude example, whereas B may have visibility to 5 data fields on the ledger for the same transaction. Okay, another example. So I made some payment to Samir, right? So let's say there's a business network. I normally like to do it in a face-to-face model where we have role plays, right? So that's a very wonderful way to understand this. So let's say there is a business network on which I, Samir, are connected. And then there is a RTO which basically governs the buying and selling or the ownership of the vehicles, right? Let's say across India. Again, a hypothetical example. Then there are multiple banks which are again on this business network because vehicles are normally hypothecated, financed by multiple banks. Then there are various insurance companies which are again part of this this network. So see, this is a big network which has multiple buyers, sellers, which has multiple insurance companies, which has multiple banks and all that, right? And the nodes, there are multiple nodes, right? So these are all nodes which I just talked about. And let's say bank have a copy of the ledger, insurance company has a copy of the ledger, RTO has a copy of the ledger, the dealers may also have a copy of the ledger, right? But the amount of information that is visible to a dealer may not be the same which is visible to an RTO. RTO may have a visibility of the entire ledger, like vehicle number X, owner Samir, when was it bought, what's the insurance value, what's the current depreciated value, when was it last serviced, everything. Whereas the dealer may only have visibility to certain fields, right? Who is the owner, right? When was the vehicle serviced last, something like that, right? So that's how we basically restrict the amount of information which is basically made available to different network partners on a single network. Likita, I hope it answers. Okay. How is blockchain useful in IoT, Tosif? Blockchain and IoT is a very natural marriage, Tosif, right? There are tens of use cases where IoT is very successfully implemented, integrated with a blockchain-based solution. I'll give you a very basic example just to sort of give you a perspective. And this is one of my very favorite examples I used to give in my sessions so often. Now, let's say somebody in Himachal is looking to ship a truckload full of apples to let's say Delhi, or maybe let's say Vizag, Vishakhapatnam. Okay, so they are looking to ship Kashmiri apples fresh from the they are from the apple farms there to some place in Vizag. Now they brought up a container which is air conditioned, Tosi. Okay, now they filled the entire container with the boxes of apples, and they maintained a temperature to a certain value, let's say 0 plus minus 5 degree or 5 plus minus 6 degrees, whatever, right, which is conducive for apple. Okay, and then they ship this. Now see, with the natural integration of IoT, what happens is the IoT device which is embedded in the container keeps sending back the temperature after every 1 hour at the backend network, right? And this temperature gets recorded on the ledger, and this ledger has multiple business network participants like insurer, buyer, seller, bank, multiple government agencies, the food department, all of them. Now the moment the temperature rises behind a certain threshold, right, so the insurance company will automatically know that the product will now depreciate, right? The quality of apple will not be the same when it reaches Vizag. Similarly, the buyer and seller will now know that the vehicle, the air condition has malfunctioned inside the container, and the manufacturer and the transporter is the one who should be paying the losses. So there is a natural integration of IoT in a lot of blockchain systems, and this is just one basic example. I can tell you tens of such examples there. Okay, Abhishek says, okay, so can crypto be a byproduct of this? Oh no, it's not a byproduct. It's actually an application of this technology. So whatever cryptocurrencies you see, their application of blockchain is a technology, right? So Ethereum is the first successful implementation of blockchain as a technology, right? Okay. Okay, every node has same privilege. I cannot restrict the nodes function to. A node cannot, Likita, a node cannot restrict other nodes' privileges. The privileges are embedded in the smart contract, and the smart contract is prior agreed before starting a network. So it's not anybody can obstruct anybody's else views. It's just that everybody knows what they are supposed to be viewing, and accordingly the smart contracts govern that access to them. Okay. Proof of work, which method is applied for reaching a consensus and private permission? Okay, so we'll just see that typically when we talk about in a Fabric point of view. So in Fabric's 0.6 release, we used to have a PBFT, practical Byzantine fault tolerance method, which used to be acting as the consensus mechanism. Okay, with new versions, we had different mechanisms saying. So with 1. Series, we started to have Kafka, and we used to have a zookeeper there. So Kafka was nothing but a messaging queue, right? Apache Kafka. Which used to use the JAB thing for that. Now with Raft, we have a different approach of, so from a permission blockchain, there is no concept of mining there, right? Because everybody knows, who is doing what. The only idea is to agree upon to the sequence of transactions, right? That's what is the entire premise of consensus in a private permission blockchain. For that, we do not need mining. We do not need a proof of work, right? For that, we need a consensus mechanism which is light on resources, right? So that's why we'll talk about Raft. We'll come later on that. Okay. Gulab says, let I deploy some machine learning model on a blockchain. How and where the model parameters will be saved in blocks, and model calculations will happen in EVM. Can we plug in our, just a moment, I'm not able to read the complete question. Can we plug in our computation machine to blockchain? Okay, Gulab, as a matter of practice, the data which is stored on blockchain has to be minimal. Why? Because we are looking at blockchain from a multi-year perspective, right? So this chain is gonna grow bigger and bigger. Bigger and bigger means you should not make it heavy. The moment you make the chain heavier, and since it's going to get bigger, it will become a problem in due course of time from a storage. It will become a nightmare from a storage perspective, right? So what we typically do is, and I'll give you one simple example. So for maintaining land records and so many similar things, medical records and all, the entire data is not brought on the blockchain, Gulab, right? What we typically bring is the data gets stored in conventional data stores, okay, and we bring the hash of the data, okay, on the blockchain. Why? The idea is to authenticate the validity or authenticity of the document which is there at the back end, okay. If the hash which is stored in the blockchain, I'll give you a small example to help this understood to you. So let's say you have a house and you have a map of the house, and you know the historical ownership of that particular land whom it belonged to 20 years back. So the current house location tagged with the map in your name is stored on a blockchain. 100 years down the lane, when somebody wants to revisit that who owned this house, 100 years back, now in order to get the information correct, what they can do is you can either store the entire information on the blockchain, or you can store the information about Gulab Patel, and then in the data, and then the address, the latitude, longitude, the historical ownership record, all of that on a conventional storage. You take a hash of that and you store that on a blockchain. So 100 years down the lane, when somebody wants to authenticate, who owned it 100 years back, they pick that hash from there in that blockchain, decrypt it, and then they go back and then they decipher who owned it. So you do not bring the entire data on a blockchain. You actually bring only a fragment. That's why typically we talk about of a footprint of a few KB, not of a MB or GB. I'll give you one strong example, in my next session when I talk about use cases, right? So whatever I'm talking about has some, exceptions as well. I'll talk about those exceptions as well then there. Okay, what do you mean by third party? Well, third party is like, an arbitrator, not an arbitrator, somebody, who provides for that services, right? Anurag, no, the 50% attack effect will not affect the Hyperledger Fabric setup. Why? We are not talking about here a proof of work or a proof of stake sort of a consensus here, right? So we're talking about permission blockchain where everybody knows everybody. Okay. Sobia is all participating node who hold the same copy of ledger. Yes, they actually hold the same copy of the ledger. Okay. How cloud is related with blockchain, Dr. Garima? Dr. Garima, multiple cloud service providers provide for blockchain as a service. Okay. Now, if you remember when I said blockchain comprises of two pieces. One, the blockchain, smart contract, which is basically the chain code or the smart contract, and then the underlying network, which connects all the network participants, right? So the cloud providers basically provide you with that service which can spin up the underlying network without you manually spinning it up. Otherwise, you will have to manually. So I guess Samir is going to do that in one of the sessions today, where you will be installing the Hyperledger Fabric, and maybe you'll be installing it in local machine, and then he might be connecting it to some multiple nodes if he is bringing an ordering service as well, but not sure about that. So I'll show you that. Hold it for a while, that how cloud is related to blockchain. I'll give you a demo in some time within this session. Okay, Amit, how is it determined that which kind of data will be showed to any particular nodes? Okay, good question. So it depends upon what is that particular node's role in that overall blockchain network, right? So depending upon the stake, depending upon the role of the particular node, you will give him that visibility. Okay, give you a certain example. So if you remember that first example of manufacturer supply chain, right? So there is again an example. There is a blockchain network which has car manufacturer, buyer, seller, dealers, warehouses. Everybody are on the same blockchain network, let's say, right? Now, there are multiple dealers on the same blockchain network which have the copy of the same ledger. But one dealer may not be interested in showing what sort of discounts is it offering to its customer to some other dealer, right? So that means that amount of information which is detrimental to a particular, vendor, so participant, will be abstracted from the other one. So that sort of visibility, that sort of granular visibility is maintained through cryptography. It is implemented, Amit, when you actually build that sort of data, when you have that sort of data. Okay. Okay, thank you, Likita. But how does one put restrictions to a node? The restrictions are again put in the embedded in the smart contract. That a smart contract is basically, so Samir is going to give you an example of commercial paper, I believe in tomorrow, and that's where maybe he will cover that piece, that how you cover the access for particular node. So node 1 can only have write access or a read access, whereas node B may only have a read access, it may not have a write access, or something like that, right? So that sort of restrictions are put in the smart contract. Okay. Yes, all participating node hold a copy of the complete ledger. Okay. No, 51% problem does not. Vidyotma, yes, I was basically taking the question, so slides are the same there. Smart contract is application of blockchain. A smart contract is a component of a blockchain application. Yes, you can say so. What's a framework? So any solution approach, for example, Fabric or Indy or Sawtooth, they provide for some libraries, they provide for some methods using which you can write an application. Typically that's what is a framework. Abhishek, it means that for crypto we need to have a specific blockchain application, and crypto is not a byproduct of every. No, Abhishek, crypto is not a byproduct of every blockchain application. You need to write a specific application, a blockchain application, to create a crypto, right? In case you want to do that. What point POS explain about? Okay, proof of stake. Explain about proof of stake. Okay. Proof of stake. Okay, so let's try to understand it from so let me try to explain it from your university system, right? So in an examination, there are multiple parties who work together, right? So there is a examination controller, there is a registrar, then there are evaluators, then there are cross checkers, cross evaluation happens, right? And all of them basically are working on a same sheet of answer copy, or answer sheet, or a question paper, or whatever you want to term it as, right? Now everybody has a stake in this overall scheme of things, right? From a registrar's point of view, or from a examination controller's point of view, it's really important that how many copies are basically evaluated per day, right? Or what is the level correctness of the level of evaluation, right? Versus from a evaluator's perspective, right? When I'm evaluating a copy, I'm basically more concerned about what is the type of content which is given in the answer for me, right? So different people will see the same thing in a different manner. So proof of stake is about what is your stake in the overall scheme of things, right? For example, when you buy or sell something, right, the buyer or staker's proof are really very high compared to somebody who is only facilitating that, right? So typically proof of stake, and then there can be multiple ways of explaining it. Okay, so I answered that. How searching occurs in blockchain. We'll talk about indexing. By storing hash of a data in blockchain will make it lightweight for sure. How can we ensure data immutability if the actual data is still off blockchain? So here, Devbrat, it's more about ensuring that the data which is available in the backend is valid or not. It's not about ensuring the immutability of that data. It's about ensuring that the data that is being considered on the blockchain network, whether this is a legally valid data or not. That's the question there. Major difference between private permission and centralized distributed system. Okay, good. Very good question. So, it's all about, when you talk about blockchain, you talk about an irrefutable proof of a transaction. That's what is the major difference there. Besides, on a centralized distributed system, you bring in multiple stakeholders, which is prone, to manipulations, which cannot be the case in with the permission blockchains here. Hyperledger transfer or shift of ledger from one org to another org. Okay, there is no transfer or shift of ledger. So let's say there is a new node joining in a ledger, right? In a network. So as a new node joins into a ledger, into a network, they basically obtain a copy of the ledger from the previous, or associated nodes there. That's how they basically join the network. Unless in case there is a forking happening, then there is a different case, right? So there is no transfer of ledger as such there. Okay, I explained private blockchain versus public blockchain. Popular job roles, we explained that. Okay. Okay, guys, I'll actually, there are a lot of questions. I think I'll have to stop for a while taking it. Let me try to see a few more questions. Okay, I'll stop it for a while and I'll come back to the chat window again, guys. Okay, so let me continue from where I left, right? So we were talking about how applications typically submit the transactions to the network, and each peer validates every transaction using the smart contracts endorsement policy, right? So the endorsement policies are embedded. Sorry, the smart contract basically has the entire business logic using which a peer endorses a particular transaction, yes or not, right? Okay, let me, yeah. So this is again a process which talks about how do you read from, how do you submit a transaction, how do you actually, once you receive the responses from the endorsement nodes, how do you submit it to the ordering service, how the ordering service actually creates a block and sends it to the committer nodes. Once the committer node validates using the smart contract, finally the ledger is updated with the transaction that you are talking about, and the application is notified about it. Okay, so let me take okay, I'll convert this first and then I'll go to, yeah. So see this is where I was talking about the gateways, right? And somebody was asking, how do you connect? So typically gateways isolate the logic, business logic, from the topology, the network topology there, right? It allows client applications to actually focus on what and not the how part of it, right? And so gateways handle the entire connection profile. I'll show that when I will go back to my my blockchain service on IBM Cloud, and I'll show you that there. Okay, so once you connect, through the gateway to the node, and that's when you can start querying there, right? You can connect and you can start querying the network there, right? And then applications can also work with multiple networks. Now, each gateway instance can connect to multiple channels. So you remember the conversation between nodes was happening through channel. So there is a green channel between P1, P2, right? You can see that. Then there is another channel which is an orange one, which is between P1, P2, and P3, right? So see this, there is a paper net, there is a bond net. There are two channels by two different names there. Now P1, P2 are part of both the networks, but they will have separate ledgers maintained for both of them. Whereas whatever conversation is happening on bond net will not be visible to P3, because the ledgers are only native to those peers on which the channel, the peers are connected to the channel there, right? As I was talking earlier, every component has a X-Forward 5.9 identity issued by the certificate authority, right? Which is used to determine the organizational role, right? And hence it determines the level of access it has to our network resources, whether it's a read access or a write access, right? Then we have the concept of wallets, which basically store the identities available to components, and multiple wallets and multiple identities can be used by same application. We use a membership service provider, MSP, to identify the identities and roles for a particular channel. We'll see that in a while. Okay. Okay, this is where we talked about the ordering service, right? So historically, as I said earlier, with 0.6, we had PBFT, the practical Byzantine fault tolerance, which had 4 nodes. At least 3 nodes had to agree, and then the 4th node had to fall in line if any transaction has to happen, right? Then came Kafka, right, which basically again was using the queuing concept, right, the Apache Kafka, right. And then we talked about Raft. So both Apache Kafka and Raft are basically crash fault tolerant consensus mechanisms, right? Why they are crash fault tolerance? Because they have multiple nodes. So even if there is one node which fails, there is another node which takes the responsibility, and the network does not go down, right? So the communication is always maintained. So ordering service role is typically to package the transaction into a blocks which can be delivered to the peers, and then the entire communication happens between the channels, right? So we already talked about this. So let's say there is a node E0, there is another node E1, right? So if you see there are two ledgers for E0. One is a red colored and the other is the black color, right? So a particular node can be part of multiple channels, and for each channel it maintains a separate ledger, right? So channel is really important. Why? Because they define the scope of conversation within a network, right? In a particular, so that's what the ledgers actually exist within the scope of channels. And yeah, so this is explanatory. Okay, now I'll actually go back from here to my browser, guys. Okay, and I want to show you a instance here. So right now I'm actually on IBM Cloud, folks. You can all have access to this IBM Cloud at no charge. I will share that in a while. But here on IBM Cloud, there is a service on blockchain, right? So let me go to my catalog here. Okay, there are multiple categories available, right, from compute, containers, networking, AI, ML, analytics, databases, logging, integration, IoT, mobility, security, all the different types of services available, right? For the conversation today, we are talking about blockchain, right? So see this, there is actually a blockchain platform offered by IBM, which helps in building, operating, and growing a blockchain solution, right? And then there is a third-party service available from Portworx as well. So on IBM Cloud, there are services from IBM as well as multiple third-party vendors, including multiple companies, right? See this? Yeah, AT&T, Baffle, Betnami, Bosch, Box, multiple companies, services available. So from a blockchain point of view, there are two services available, but the one that we are going to talk about today is the blockchain platform. Okay, the blockchain platform actually provides us a very flexible way to build and operate our blockchain network, right? See this. This is the way you create a service, but what is important about is what this service provides. This service basically provides for building your network. See this? I was telling about this. So in a blockchain solution, two major components, the blockchain network and the smart contract or the chain code which sits on top of it, right? So that underlying piece of blockchain network is what this service spins up for you. And it operates and it governs the network for you without you actually getting bothered about all of that, right? So what it does, it basically uses a Kubernetes cluster underneath on which it hosts the the IBP, the IBM Blockchain Platform Service. So I've already spun up a service here. This is the once you spin up the service, this is how it will look like. Okay, see this? Using the service, I can define my architecture. I can develop a smart contracts. I can build a network. I can join multiple networks through this. I can deploy my smart contracts using a continuous build and deploy mechanism, a pipelining approach. Then I can monitor my resources. I can, do the channel governance as well. All of that is possible. I can grow and I can grow my network from here. Okay, so let's try to understand here. What is this platform doing? Okay. So as I said earlier, right? A typical blockchain will have some peers, some certificate authorities, some ordering service and all. So I've already created, a couple of nodes, a certificate authority and an ordering service here. Okay. I have this, okay, I'm having a connectivity issue, means my network is, not very great today. So I have not deployed any smart contract so far, but it says Fabric version 2.0 lifecycle is available, so I can, install both 1.4 based Fabric 1.4 based smart contracts versus Fabric 2.0 based smart contracts. So those of you who are new to this, please do not get worried by this. Ever since the Fabric was was launched, it has got multiple versions released so far. So the first one was 0.6, which is legacy now. Then came 1.0, then 1.2, then 1.4, and now finally we are having version 2.0 based Fabric, right? So it releases now. So there can be systems which may be still old or working on Fabric 1.0, because Fabric 2.0 has so many new features which 1.x did not support earlier, right? So that's why I was actually the private data collection feature, which I skipped for then. I said I'll come back to it later. That's basically a feature with Fabric 2.x 2.0, right? Okay, so IBP supports both the versions, both the Fabric versions so far, right? This is the wallet where you store the identities, or you as in the platform stores the identities. This is where you can create organizations, you can define organizations, you can create the MSP definition, which I was telling you earlier, right? These are the users which are already defined, which you can do that, and then you can have multiple settings how to actually control all of this here, right? So okay, now this is typically running on this Kubernetes cluster, guys, which is already deployed by me. Now this is a 30-day free Kubernetes cluster which I'm using. Now how do you get access to this? Let me share that piece with you, right? Now most of you in this room will have a institutional email ID, guys, right? A college provided email ID, right? Now, in order to access this, all we need is, let me share. Yeah. So IBM provides for something called as a IBM Academic Initiative platform, using which you can access all of this there. Okay, so let me show it to you. So here, this is like a one-stop learning platform, guys. Okay. So whether you want to learn about cloud, or you want to learn about AI, or you want to learn about blockchain, you want to learn about automation, data science, security, quantum, whatever you want to learn, you will get content across all of these things here. I'll give you a small, thing about data science, and it'll go to blockchain here. So let's say anybody in this room wants to learn about blockchain, like for example, okay. Now, this platform is entirely free. There are no charges associated, by the way, guys. All that you need to have is you need to come here with an institutional email ID, something at the rate your college domain. Okay, you cannot come and register with a Gmail, Hotmail ID here. Okay, so there are multiple courses available over here, which are self-learning. You don't need anybody's help here, right? For example, if somebody wants to understand what is data science, getting started, this is like 3.5 or 4-hour course or a 5-hour course, which somebody can learn from here, getting started with data science. Similarly, how is data science being leveraged in healthcare today, right? So there is a 1-hour course which can be taken up. Each of these courses, when you complete it, you also get digital badges, by the way, okay? Similarly, if you want to get hands-on with this, right? So you can download the licensed software from it, right? For example, you can download iLog CPlex from here. You can download SPSS Modeler, Cognos Analytics, IBM DB2, even other software are available over here, right? Which you can download. Similarly, from a cloud perspective, you can get access to IBM Cloud at no charge from here. See this? In the software tab, I can get access to IBM Cloud from here. And after that, I can get a promo code, a feature code, which will give me $200 worth of credit every month for 1 year. So, $2,400 per year of cloud credits I will get for using, right? So I can create an account from here, and then I can, put a feature code on that account, and then I can keep it using for 1 year or more. It is available till the time you have the institutional email ID. You can continue using without any charges the IBM Cloud, right? Okay, and also in case you are new to the cloud, you can, again, there are courses available on how do you get started with cloud. Again, a very foundation course, 4-hour course, self-learning. Again, how do you use cloud and healthcare, and so many others, right? So whether it's cloud or healthcare or security, there are courses around all of these technologies. and there are licensed software available as well. Similarly, if you talk about security, right, there's a course available, then you can download this various software available from here, and these are all licensed enterprise software, guys. It's not so you can download it safely. You can use the licensed version. Your students can also use it, right? Okay, let me go back to the cloud. So let's say you have access to the cloud, and you have created a blockchain service on the cloud, right? So that's where this example that I was trying to show you, right? Now, once you have this, I can help you create all these peer, certificate authority, ordering service, all of that there. Now, to do all of this, you have to, this service is running on a Kubernetes cluster for me, right? Which is, again, it's again a 30-day cluster, which is being used over here. So in case you want, you can get access, and I can help you. How do you get started with this piece? Okay, any questions so far? Okay, now you can put your questions on chat, guys. I'll quickly take these questions before we wind up for this, and I'll come back for the next session, and we'll talk more about the fabric. Okay.
Dr. Mani, can we have a small break? Some people are asking for that.
Oh, sure, ma'am. It simply missed my mind. I was actually carried away with this.
So
sorry.
There are always so many questions, and that shows the enthusiasm of the participant. Your session is going on so well. It is attracting so many questions. So we'll have a small break if you don't.
Sure, ma'am. We can take a break here, and we'll come back and we'll take all the
Sure.
Sure. Look forward to see you again. Thank you.
Thank you.